How do we learn? And why do some people seem to learn faster than others? Modern brain science gives us a clear and powerful answer. Every time you learn something new, your brain changes. This ability is called neuroplasticity, and it is one of the most important discoveries in neuroscience. For a long time, many people believed that the brain stopped changing after childhood. They also thought we used only small parts of the brain, and that the brain became quiet when we rested. Today we know these ideas are wrong. Even when you are resting, your brain is still active. And your brain can keep changing throughout your whole life. This is great news because it means learning is not only for children. Adults can still improve, adapt, recover, and build new skills. In fact, your brain is always being shaped by what you do, what you practice, and even what you avoid. When you learn, the brain changes in three main ways. First, it can change chemically. Brain cells communicate with each other through chemical signals. When you start learning something, these signals can increase very quickly. That is why you may feel better at a task after only one practice session. But this kind of change is usually short-term. Second, the brain can change its structure. It can build and strengthen connections between brain cells. These physical changes take more time, but they are the basis of long-term memory and lasting skill. This explains something many people experience. You practice a new skill and improve a lot in one day. You think, I've learned it. But the next day, much of that progress seems gone. Why? Because your brain may have made fast chemical changes, but not yet the deeper structural changes needed for long-term learning. Real learning takes time. Third, the brain can change its function. When you use certain brain areas again and again, those areas become easier to activate. Over time, whole brain networks begin to work together more smoothly and more efficiently. This is why repeated practice can make a skill feel natural. These three types of change, chemical, structural, and functional, often happen together. They support learning across the whole brain. Research also shows that different experiences shape different parts of the brain. People who read Braille often have larger brain areas connected to touch. The brain area linked to your dominant hand is usually stronger, because you use it more. People who must remember complex maps can develop stronger systems for spatial memory. In simple words, the brain changes according to the work it does. But if the brain is so flexible, why is learning still hard? Why do some children struggle in school? Why do people forget more as they get older? Why do some people recover better than others after brain injury? The answer is that neuroplasticity is powerful, but it also has limits. And most importantly, it does not work in exactly the same way for everyone. One of the most important lessons from brain science is this: behavior is the strongest driver of brain change. There is no magic pill for learning. Practice is still the most effective tool. If you want to gain a skill, improve a skill, or rebuild a lost skill, your brain needs repetition. And usually, it needs a lot of repetition. There is another important truth. Struggle is not always a bad sign. In many cases, greater difficulty during practice leads to deeper learning and stronger brain change. If something feels challenging, that may mean your brain is doing important work. At the same time, neuroplasticity can work in both positive and negative ways. It can help you build useful skills, healthy habits, and stronger thinking. But it can also strengthen fear, addiction, chronic pain, bad habits, and avoidance. Your brain is shaped not only by what you do, but also by what you do not do. Brain science also teaches us that there is no single best way to learn. No one method works for everyone. You may have heard the idea that mastery always takes a fixed number of practice hours. Real life is not that simple. Some people need much more time. Others need much less. Every brain is unique. That is why personalized learning matters. Instead of asking, what is the best method? We may need to ask, what is the best method for this person? The structure and activity of each brain can affect how someone learns best. This helps explain why some children do well in traditional classrooms while others do not. Some people learn languages quickly, while others learn sports more easily. These differences do not mean one brain is better than another. They mean brains learn in different ways. So remember this, your brain is always changing. Practice matters more than talent alone. Progress is often uneven, and that is normal. The best learning strategy is personal, and challenge is often part of growth. The most important idea is simple. Every experience changes your brain. Every habit, every skill, every repeated action leaves a mark. You are not just using your brain. You are building it. So pay attention to how you learn best. Repeat the habits that help you grow, break the habits that hold you back, and keep practicing. Go build the brain you want. Have a nice day!